All right, here we go. We are going to talk a little bit about how do I use samples to predict information based on what I had already collected as data. Our essential question for today is how do you use data samples to predict outcomes? As always, I'm just going to read through these and leave them. If you need to pause in order to write more, go ahead and do that. Definition of sample. A sample is a selection taken from the larger group or population so that you can examine it to find out something about the larger group. A population is the whole group from which the sample is taken. The population is the whole group from which the sample is taken. An example would be if I went in and I asked randomly 100 different people at a football game what their job is. So I walk in, find 100 people randomly, just walking around and ask them what their job is. The sample that I talked to is just the 100 people. Only the 100 people that people were at the game is who I talked to. The population is everybody who was there at that game. We also have to realize that some surveys and some questionnaires are biased in that they're going to lead you down a certain path to get you to say what they want you to say. And so we have two different types of samples, some that are unbiased. An unbiased sample is a sample that is selected to accurately represent the entire population. Unbiased sample means it's not leading in any one direction, way, shape, or form. It's open to all different opinions, ideals, beliefs, groups, whatever the case might be. A biased sample means that it favors one part or another. An example of this might be if I was going to ask the new 6th graders if they liked their part of the school building, which was newly built this year. And if I was to go over there and say, hey, do you think the school is built well? They're likely going to say yes, because everything in their area is new. New lockers, new carpet, new furniture, new technology in their classrooms. That would be a biased sample because I'm not talking to the kids in the school as a whole. So what we're going to do is look at these following two questions, questions number 18 and 19, and we're going to say whether or not these, if they're biased, and if they are, explain why. So it states that a survey may be biased if it contains questions that are worded to influence people's responses. Explain whether each survey question may result in some sort of bias. So question number 18 says, this semester we read the popular Journey series. Did you enjoy the books? This question in and of itself seems innocent enough, but this one word right there gives this a bias in one way or another, because what I'm telling you is that this is popular, and if you haven't read it, then you're missing out on something. This one word is going to skew my data. Question number 19, name your favorite baseball team. This question, it's not biased. It's just, what's your favorite team? Now, this could potentially be a biased question if I was standing in front of the Target Stadium, Target Field. If I'm standing in front of Target Field and asking the people, what's your favorite baseball team? Most of them are probably going to say the Twins. I can't run out and then say 90% of people say Twins are their favorite team, because that would be biased because of where I was standing. So sometimes it's in the question, and sometimes it's where you are when you're conducting that survey. All right. Determine whether each conclusion is valid. So here we go. We have a radio station. It's going to ask its listeners to call one of two numbers to indicate their preference for two candidates for mayor in the upcoming election. So we got a radio station. They're going to see if they can determine who's going to win the mayor election. 72% of the listeners who responded wanted candidate A. 72%, that's a pretty decent percent. So we have 72% who want candidate A. So the radio station says candidate A is going to win the election. We need to determine, is this reasonable? Is this biased? Is this unbiased? Well, what radio station was it? That is going to determine whether or not this is a reasonable justification, and it's not. 72% of people who listen to this radio station, I don't know what kind of radio station this is. It might be a kids radio station. It might be a radio station that is specific in one kind of music. Maybe it's all oldies, maybe it's all swing music, maybe it's all hip hop or new music. So this is not an accurate statement for them to make. They might be able to say something of the listeners to our station, we believe candidate A would win, but to say that candidate A is going to win just because of what happened at their radio station is not fair. All right. To award prizes at a sold-out hockey game, 4 seat numbers are picked from a barrel containing individual papers representing each seat number. Tyler concludes that he has a good chance as anybody else to win a prize. This would be accurate. They're not specific papers, as long as they're all the same size and all the same, or the different numbers are on there and every single number is included, as long as a certain seat number isn't written on there more than once, he is fair to say that he would be equally likely, just as likely as anybody else, to win a prize. We are now going to move on to, we've got good questions, we have a good survey, we randomly talk to people. Can we use that information to predict? What we need to remember is how to set up a proportion. Proportions are 2 fractions that are equaling each other. 2 ratios. All right, question 1, communication. The student council advisor asked every 10th student in the lunch line how they preferred to be contacted with school news. The results are shown in the table. If there are 680 students at the school, how many can be expected to prefer email? So we've got a few things going on. First, we know 680 students are at the school. What you also need to realize is she did not talk to 680 students. She talked to 16 students who liked email, 12 students who liked a newsletter, 5 who liked an announcement, and 3 who would prefer to be contacted via telephone. So when we add all of these up, we're going to find out that she really only talked to 36 kids. We want to know, if there are 680, what would those results possibly look like? So the question here is email. I want to know how many liked email compared to the total amount of kids. Same thing again, how many liked email compared to the total amount of kids. So this right here is going to be my proportion. Then what I need to do is set up some numbers. I know that 16 kids out of the 36 liked email. So my 1 ratio could be 16 kids out of 36. Over here then, I need to set it equal to another ratio. In this case, I have 680 students total in the school. So the 680 is going to go down to the bottom, and up here I would have the X for what I don't know. Then, just like all the other problems we've done, we're going to cross multiply. This is going to give us 36X, and the other one is going to give us, as we cross multiply this way, 10,880. Then what we need to do is railroad tracks, divide both sides by 36, and I get an answer of about 302 kids. I could expect about 302, which is a little close to half, because this is close to half, so that would make sense. My calculator says 302.2, so I could say, well, if it's 0.2 kids, I can't have 0.2 of a kid rounded up to 3, but I know most students would say, well, 0.2 rounds down. So I'd go with either one. I think 303 is a better answer, but either one would be fine. Here we go, golfing. Zach is trying to decide which of 3 different golf courses is best. He randomly surveyed some people at a golf store and recorded the results in the table. If he surveyed 150 people, how many people would be expected to vote for Rolling Meadows? Now again, Zach did not talk to 150 people. The question here says if he was to do that. He didn't really do that. I do know, however, that that's what I'm going to want my total to be. I want my total to be 150, but I don't know how many want Rolling Meadows. I do know that he talked to 10 people who liked Whispering Trail, 8 people who liked Tall Pines, and 7 people who liked Rolling Meadows. Altogether, he talked to 25 people. This is his total. So down here, my total is 25 people. I know in this example that 7 of them liked Rolling Meadows. I can solve this using cross multiplication, or I could also say, hey, to go from here to here, it's times 6, which means I could also go times 6 from here to here. So Rolling Meadows, I could expect, would have about 42 people would vote as that one being their favorite. Here, we don't have a table, so we have to read the problem and see where the other data comes from. A swimming instructor at a community pool asks her students if they would be interested in an advanced swimming course, and 60% stated that they would. If there are 870 pool members, how many people can the instructor expect to take the course? Again, here's the big if. If there are 870, which means I did not really talk to 870, so that needs to go on the bottom. The number of people taking the course would go on top. I don't know how many it would be. Now, this is where we get a little bit, some struggles at times because we don't have the table to count how many people we talk to. The beauty of this problem is that it's a percentage. And we know all too well that percents always go over 100. So then in this case, in order to solve it, I'm just going to multiply or cross multiply. In this case, if I was to cross multiply, I'd have 100x. And if I was to cross multiply this other way, I would have 52,200. Whoops, 52,000. See, we back that up again. 52,200. Then I would divide both sides by 100, and I would find my answer to be 522. 522 people should be expected to take the course, which seems reasonable because it's more than half, and 60% is more than half of 100. We have a store. They're selling different kinds of pants. They're selling jeans, capris, cargos, and khakis. The people who worked at the store survey 50 customers. They tell me that's how many they survey. Watch this. 8 plus 7 is 15. 15 plus 10 is 25. 25 plus 25 is 50. There's my total. They did this at random, which is nice because that's going to give me an unbiased survey. The types of pants they prefer are indicated in the table if 450 pairs of pants are to be ordered. I haven't done it yet. I'm just saying if I was to do that, well, the 450 would go on the bottom. How many would be jeans? Well, jeans would go on the top. I go back over here and say, you know what? 25 people, when they were surveyed, said they liked the jeans out of the total 50 people we talked to. Here you can do a few things. Cross multiply, multiply this way knowing that it's really going to be the same thing as times 9. Or you could say, well, this is 1/2, therefore half of this is 225. The math is different ways to do that, but it's all going to get you to that same answer. All right, hopefully that was enough to help you understand how to solve samples and predict. Remember to always set up your proportions in order to solve. It's going to help you out much more and lead you to the right answer. Thanks, have a great day.